Hello everyone. Today we are going to discuss the problems of weekly LeetCode round 345. So we are going to discuss maximum number of moves in a grid in this video, and let's read the question. So the question is like, you are given a zero indexed m into n matrix grid consisting of positive integers. You can start at any cell in the first column of the matrix and traverse the grid in the following ways. From a given row, comma column, you can move to row minus 1, comma column plus 1, or row column plus 1, or row plus 1, comma column plus 1, such that the values of the cell you move to should be directly bigger than the value of the current cell. So return the maximum number of moves that you can perform. So basically, let's abstract the information from this question. So here we have taken the provided graph in the input. So the question is like, from we can, so there are m columns and n rows, right? So these are these n rows and m columns. So we have to start from we have to start from the first column only, right? We can start from this column. So we can start from 2, we can start from 5, we can start from 3, we can start from 10, and we have to from a given index, let's say for a given I comma j, from a given I comma j, you can move to I plus 1 comma j plus 1, right? Or you can go to I comma j plus 1, or you can go to I minus 1 comma j plus 1. So you can from a given index I comma j, you can traverse to I plus 1 j to this. You can traverse to this index, you can traverse to this index, and you can traverse to this index in one move. So you have to tell how many possible moves you have, so that from a given index of I comma j, the next index is greater than the value of the next index is greater than the current index. Let us say you are stand here. You can you can go to from the given condition, you can go to this index and this index. If you try to go to this index, then you can go outside the grid. So you have to remain inside the grid, and you can perform these three moves. So in one first move you can go to 4, and also you can go to this 4, because the value of this 2 is strictly less than 4, right? And from this index, now from this index 4, you having two choices. You can go to 3 and you can go to 9, but the 3 is less than 4, so you have to go to 9, right? And from this 9, you can perform 3. You have three choices, like you can go to this way, you can go to this index, or you can go to this index. But 5 and 3 having less value than 9, so that's why you have to go to 11. From 11 you can't move further. So total there are how many moves there are? So there are three moves: first, second, and third. So from a given if you can traverse from any of the element of the first column, and you have to perform in such a way that the value of the grid which you are traversing is less than the current value of the grid, right? So uh, So from 2 you can, from 3, from 5, if you try to build this, you can't go anywhere. So from 5 it's be 0, from 3 it's then it's also 9, and from this is also 9, right? And yeah, from 2 you have to perform 3 moves, and from 5 you can perform none move, because if you're trying to go to 4, then you can't go to 4, because the 5 is still greater than 4. And if you go from 3 to 4, then you go to 9, then you traverse this way, right? So there are 3 ways in from these 3 or as well. And when you try to move from 10, there is no move, because all the values where he can traverse is less than 10. So that's why there is no way to move from 10. So uh, it's what you do, what you can do, you can just take the take one by one all the elements of the first column, and you traverse the maximum possible length which can you traverse along from a given position. Let us say from 2 you can move to till this position, right? So you check from this and this and this, so and take the maximum value among them, uh, from where you can perform as many as moves, right? So let's build it. So let's the approach to do this question, uh, basically I take all the elements of the first column one by one. So first I take 2, and I take the indices of 2, right? Let's say this is a zero based index, so the indices of 2 is 0 comma 0. So from a given 0 comma 0, I can move to 1 comma 1, 0 comma 1, and yeah, only two moves, because when I perform this I go outside the grid, so this is not possible. So that's why we from this two I can go to this. So I just store the next index where he can go. So it can go to 0 comma 1, right? I store the next index, and I increase my count. I increase my counter by 1, because I have performed first in one step there. So from this 0 comma 1, from this 0 comma 1 you can go only this. So you can only go to you can only you can only go to 1 comma 2, because 0 comma 2 is less than 0 comma 1. So that's why you can only perform this. So you also increase the counter. This is important because you are storing the answer in the count. So you increase the counter by 2. This 2 refers me that there are two moves. The From the given index we perform two moves, right? So from this 9, I can go to only 2 comma 3, because all 5 and 3 are lesser than 9. So from this I can go to 2 comma 3. So I store 2 comma 3 in my queue, and increase the counter by 1. So plus 3 denote the we perform 3 moves till now, right? So uh, we perform this, and from this we can't go to any index. So that's why we terminate at that point for this value 2. So what can I do? I can just store these indices in my queue, and store this in my queue, right? So I store this in my queue, and when I perform the operation from this, I just pop this, right? And I store the next index in my queue, and when I perform the operation, then I just pop out. So at the last we can't perform any new operation. So at that point I just popped out and my queue become empty. So at that point I terminate from this. So let's see the code, which will give you a better understanding what I mean to say. So let's check the code. So basically I store I initialize max with 0. In max I am storing the answers mx, right? And I in n and m I store the number of columns and number of rows, and I create a 2D vector of visited, which denotes whether I visit a cell or not. So so if I visited this cell, let us say I visited 4, so I can't visit it again because I know all the possible moves from this index, right? I store all the possible moves from this index, so I can't have to revisit it, right? So that's why I only visit particular cell only once. So in this I store the number, the sequence in which the moves perform, like -1 and 1 denotes -1 and 1 denotes -1 and 1 denotes this move, 0 and 1 denotes this move, and 1 and 1 denotes this move, right? So I stored them already uh, in a in a array, which will ensure that I uh, don't have to do if and else more than once. Then I traverse to all the rows of the first column, and I take column as a column average, every time column as 0, and store this is storing the count, the number of moves I can perform. So this is initially 0 because I don't have perform any move yet. So then I visit this cell, and I then in this while this I ensure that when the queue is empty, the loop is terminated. So int row means it's denoting the rows, the row index, right? And int column denote the column index, and count denote the number of moves we have performed yet. Then I do this max because I'm storing the maximum. I have to return the maximum number of moves I can perform from a given index of the first column. So this store that, and every time I have to pop because I can because I am storing all the possible moves from that index. So I don't need that index more. So I have to pop this out. So and this loop is giving the all the possible uh, grids, all the possible indexes where we can go, and I ensure that the index of the grid is greater than 0 and less than n, and I check where the current grid is the where I traverse now is greater than the previous grid where we are coming from. Means the current grid in which we are is greater than the previous grid from where we are traversing, right? And this is also that the given grid is not visited yet, because we have to visit a grid only once. So and then if this holds, then I have to just push the indices of the rows and column in the queue, right, and visit the cell. And if I found and finally I have the maximum number of moves which I perform from any given cell in the first column, and I have to just return it. So I hope the problem should be clear to you all, and for more such videos, subscribe to our channel, and thank you.